Okay, let's discuss question number 4, 5, and 6 in this video for the same worksheet. Question number 4, it says how many moles of chlorine gas are needed to react with 1 mole of methane gas to form trichloromethane? So basically, addition of chlorine with methane, that's alkane, right? So it's a substitution reaction. It is a substitution reaction. So alkanes undergo substitution reaction, right? So let's see what happens when we add chlorine with methane. In methane you have four hydrogens. Substitution reaction is just a replacement of one element with another. Okay, here chlorine is getting substituted in place of hydrogen. So when we add 1 mole of chlorine, Cl2 is one mole. Okay, so when we add 1 mole of chlorine, if you see the product, you are getting chloromethane. You're getting chloromethane. Okay, so one hydrogen is replaced by one chlorine and you're getting additional product HCl. No need to worry about the additional product. So the name of this is chloromethane. Why? Because there is only one chlorine. If we add one more mole of chlorine with this chloromethane, we get dichloromethane. Okay, we get dichloromethane. If you see, one more hydrogen is replaced by another chlorine. So we are getting dichloromethane. We need to add one more mole of chlorine to get trichloromethane. That is what your question. Okay, so if you notice, among the four hydrogens, two hydrogens are replaced already in dichloromethane. If we add one more mole of chlorine, another hydrogen is getting replaced and you are getting trichloromethane. Okay, trichloromethane. So this is the answer for the question. So if you see from the top, how many moles of chlorines are being added? 1, 2, and 3, right? Now, in case, suppose, yeah, if you are asked to find out tetra means 4. Okay, it's not there in the question, I'm just giving you additional information. If you are asked to find out the number of moles of chlorine for tetra means 4, we just add one more mole of chlorine with this trichloromethane. So we can remove one more hydrogen, the remaining hydrogen, from the methane to make it like this. So this is tetrachloromethane. Okay, this is not in the question, I'm just giving additional information. So for the question, we need 3 moles of chlorine to form tetrachloromethane. Okay, I hope it's clear. Question number 5 is similar to question number 4. The difference is you're just asked to find out the value of, the chemical, the alkane of X, Y, and Z. Okay, what is the alkane X, what is alkane Y, what is the alkane Z? Now if you notice, if you follow the same method as we did in question number 4, now the products are given here. For X plus Cl2 gives chloroethane, right? If there are two carbons with for the alkane, the name should start with eth, right? So this is chloroethane, right? So what can be added with chlorine to get chloroethane? So it should be ethane, right? So the answer for X is ethane. If you see for the next one, Y plus Cl2 gives the product is, there are three carbons, so the alkane with three carbons is propane. So Y should be propane. So when we treat chlorine with propane, we get chloropropane. Okay, chloropropane. Then if you notice for the next, the third one, there are four carbons. So the alkane with four carbons should be butane, right? So when we treat butane with, sorry, it was wrongly written. So Z, okay, when we treat Z with chlorine, that is, there are four carbons in the product, so it should be a butane. So the answer is X is equal to ethane, Y is equal to propane, and Z is equal to butane. I hope it's clear. Yeah, please feel free to ask questions if you have any still. For question number 6a, you're asked to find out the molecular formula of propene. So for prop, it's with three carbons. Okay, ene, so there should be a double bond, it's an alkene. So apply the general formula CnH2n for alkene. So prop is 3, so if you substitute the value of n in the general formula, you will get C3H6. Okay, now you're asked to write the structural formula of this alkene, propene, right? So this is how we can write. The double bond can be either this side or that side, no matter, both are same. So there should be three carbons, C, single bond C. Since it's an alkene, there should be a double bond. Okay. So rest of the things are hydrogens. I hope it's clear.